So now we have both. We can go ahead and send to VXModel. Okay, good. So we still have the same color teams and everything. Things are just moved around a little bit. Okay, no big deal.
This is triangles now? No.
That's just an STL. At this point, this is just an STL. It's just a collection of triangles.
So is it less data, more data?
Triangles and wireframe. So that's showing us
Oh yeah.
the result of our decimate and enhance. So we have a whole bunch of small triangles to define our edge,
Right.
and where it's all nice and flat, we don't care. We got nice big ones.
That's awesome.
So it's the perfect compromise of file size versus quality. So I'll display as triangles, keep it smoother that way. I mean, you could, if you know, could even show the point cloud. So that's how many points we mapped in space. At this point here, this is an oversimplification. I think it's really just like the points of where the triangles intersect. But transparent triangles. So this usually is the preferred view just to see how smooth things are. And that. Another thing we have here is, I believe, yeah, material glossiness. If we bump that up, it helps us highlight the high spots. It helps us highlight the defects on where and what would need to be filled. That's nice. We lost that. We don't have that anymore in our newer versions. I don't think, anyway. And then we also have a clip view. So if I'm like this, and then I do clip view, so it's as per the orientation I was, and then
Oh wow.
I play with the slider. It's a quick one in the moving. So I'll go back to the tree view over here. So here we have, I like to call them, I'm jumping ahead here, but we have our green team, which is all about entities, auto surfaces, and alignments. Then we have like sort of like light blue team, which is delete, copy, cut, and clean mesh. We usually always run a clean mesh when we enter a new STL into our session. It's like an extra cleaning after to make sure we start off okay. And we'll run it at the very end. When we're done with this and we're ready to either do something, you know, bring it to something else, or before we finalize stuff, we'll just go ahead and run that at the very end in case we've created holes. Sometimes we'll end up trimming stuff and then filling holes, but we might end up with some floaters and some stuff in that process. So to get rid of that and make sure that we're good everywhere, we run it at the very end.
So clean mainly fills holes and gets rid of floaters. Is that
It also despikes, and in some cases it could get rid of narrow bridges. So we purposely want to keep those because sometimes it gives us something to latch onto. But often it's going to get rid of self-intersecting triangles, spikes, stuff that would make the object like freak out in a 3D printing slicer.
makes it waterproof or watertight?
It helps. It doesn't guarantee watertight. We have the watertight for that over here.
Okay.
That guarantees it's watertight. There's the clean mesh. Then we have our orange team, which is all about improving, and that's where we're going to fill holes, edit boundaries. That's mainly what we're going to play with now. And then we have purple team, which we call edit. So that's where there's watertight, but it's also where you can mirror, scale, extend boundaries, cut boundaries. You're veering off of the original part and you're making a copy. You're playing with something. You know, you scanned a car. You want to be it's watertight, but like you want to print at 125, but you go ahead and scale it down to 125 and 3D print it. So depending what, or example, you're making a machine and you can only scan the right side part and you know they're perfectly symmetrical. If you have your right side and you've got it all good, you can go ahead and just replicate, duplicate that and put it on a 3D slicer, make sure it works, 3D print it. Oh yeah, okay, it's good, it's what I want. Then you can machine it, you can do whatever. So yeah, so that's purple team. Then we have, apply texture if we want at the end, because sometimes, maybe your end result is that you're scanning a car for Gran Turismo 7 and you want a nice STL model of a Lamborghini or something, you want to have the texture as much as possible. Want to apply that for your digital scene, your digital mock-up, and then you have combine and merge, so you can import something else, put it together, or one inside the other if you're doing a space claim thing, maybe without having to go into CAD software. You can do to some extent some stuff here. So example, this, when I talk about space claim, is, I don't know, for whatever reason, this fits in a box, or it's a space between something else. So I want to bring in that something else and make sure that if I scale this plus or minus something, it's still going to fit in the box. Or, I need to design something around this. I need to know that this is in space, and then my other thing is going to be on one side, the top, the bottom.
Sounds like a Dutchman.
So here I'm going to go ahead and run clean mesh. And this is an iterative process, usually. Okay, there's really not a lot, so it's going to deal with it. But like if I have higher numbers here, if I have like thousands of spikes, like 3,000-4,000 spikes, and thousands of self-intersections and stuff like that, I might have to run it a couple of times. I might have to run the wizard itself a couple of times for it to really clean it all out. This should be done in one shot.
What's a narrow bridge?
It's like a little sliver between two.
A little gap, no? Like a gap in the line?
It's a bridge, right? Like a piece that
It's
goes
like
from
a
one
thin,
piece to another?
yeah, but it's like, imagine big holes on either side of it. I don't know if we have a narrow bridge here.
95.
95. I'm gonna try to zoom in and see what's a narrow bridge. So that's the spikes it's picking up. It's
So
a little-
whatever is check marked is being
Okay,
highlighted?
this is a narrow bridge. See how there's a big hole
Yeah.
on this side and on that side?
Okay.
That's a narrow bridge there because it's only 2-3 triangles stitched together.
Mm.
But I don't want to get rid of that necessarily. I wouldn't want to ditch this because I could latch onto this to fill a hole after, the way I would want it to be.
Is that why it's kind of defaulted as not being?
That's right. That's why if you want to get rid of them, that's so you can check it and then they'll disappear. But I'd rather keep as much original data as possible if I'm going to bridge and fill holes and stuff.
Yeah.
At least I'll have the original data to come and stitch onto.
Mhm.
Even if it's not a lot, it's still something.
Could be a legitimate connection.
Exactly,
Yeah.
exactly. So I'm gonna hit apply. So it's gotten rid of some stuff for me.
So it's highlighted what was removed, is that what that, it was red and now it's,
Yeah, I'm just gonna hit, okay. And see, there's less narrow bridge, or there's more narrow bridges now than there were before.
but it pretty much got rid of everything else.
Oh, I see. It's because, there we go. I was still seeing scan 1. The gray was the difference between my scan and my actual mesh that showed up.
Is that the stem that we're looking at there?
I think so, yeah.
Okay.
So again, I am a little okay. I have a bit of depth info here, but this is going to be a bit of a trick to reconstruct properly. Let's see here. Depth definition is a little wacky.
Can you just make like a rectangle and then push it down or something?
You gave me a fantastic idea, but we can't do it in this version. Shit. Oh, I could do something else. Okay, it's gonna be some tickling, but I think we can do something. Because we have in the later version, we have a sculpting tool. And we can say emboss or engrave by how much wet tip shape. So we can actually push in and like write our name or whatever.
I
So you
suppose you could
can,
do it after too, right? Like the whole idea here is just to get a pretty good representation of what that is, and then we're gonna reverse engineer it so that it's a really
That-
clean model that we can bring into SolidWorks or bring into Top
Yeah.
Solid. I know you can do that late in there, maybe easier.
yeah, you won't get the model per se unless you do an auto surface. But what you'll get is all entities. Properly placed on which you can just draw from and remake it, if you will, in SolidWorks. And the reason for that is because you don't want to necessarily carry over the manufacturing error of what you scanned in what should be your CAD perfection.
Right.
You need the engineer in between, in most cases, the engineer in between to make the right call.
That's
Right.
interesting though, cause in our case, we do want the imperfections, I think, cause we're trying to replicate.
Yeah, you're really trying to replicate. Right, yeah, so in your case, you do a lot of auto surface, I think, and that way you'd carry over your model pretty much as,
Oh, really, there's an auto surface?
Yeah.
So you don't have to draw a rectangle.
That's
on the
right.
Bottom, oh, okay.
that's right. As long as this guy's cleaned up to enough to what you
Yeah,
need it to be, you can go ahead and just wrap it up in a surface, save that as a parasolid if it's watertight, and then you have your solid CAD that can be worked from.
that's good to know.
But then that means cleaning it up here, making it as clean as you possibly can here,
Like
to
in some-
save yourself the legwork later.
Like in some cases, like, that's why I brought this one in, like, this is a window jamb, but it's got a lot of weathering, so we'd wanna like scan this, but then we'd want this to go back to flat, right? Cause we wanna replace it with, we wanna cut something that's not, that doesn't have all these parts, right? You know, or these weathering bits. So that would be a case where we would probably draw a rectangle, like a new entity.
Because then you'd have to reverse engineer it in SolidWorks, for example. If you wanna get rid of that imperfection, or,
Isn't that what we were doing yesterday, Rob? Like, we were drawing entities on top or something. I remember there was the one example where it was like, a part and it had a rectangle and had a cylinder taken out and had a cone on top. So they were basically just like resurfacing that. That's what I kinda see is that like, we don't wanna cut it like this, we'll scan it like that, but we wanna clean it.
this is a pain in the ass, I see you don't have the sandpaper tool. So those are the two missing here, the sandpaper and the sculpting. That would go a long way. So I'm gonna use the brush. And I'm gonna hover over,
So that whole panel, those are basically just selection tools.
yes,
Yeah, the whole selection suite. Okay.
I'm gonna run through, through them. So what we have here is basically, this is just your regular rectangle.
Yep.
Okay, I'll start over. Then we have freeform. So that's, I either pick, I can click and hold if I want.
Right.
I like to say ranch Doritos to clear the selection, regular Doritos to select all. We did this one, which was invert, flip the selection.
And what's the first one? It's like 2 layers.
That's the through all. That's the slices of cheese I was talking about. The difference here being, this, I'll illustrate it very simple. This is not active. I use the brush and I go here. Only this is selected. Only this face.
Yeah.
Now if I clear, I go through all. Oh, would you look at that?
Right, that trajectory.
Where I was, the trajectory just sliced through the whole thing. So that can be very handy to get rid of all those clingers, but be very careful that you're not grabbing something on the other side.
Is it the trajectory that we're looking at? Or
Yeah.
is it perpendicular?
No, it's what you're looking at.
Oh, that's weird.
Yeah, it takes a little getting used to.
Is there a way to like, quickly reset that so that we are looking at it flat?
Once you have your coordinate system set up, yes.
Okay, but not.
Not right now
It's all
because,
relative to how we scanned it.
yes,
Yeah.
right now the coordinate system is over here.
Right, okay.
So not really.
Yeah.
We could change it now too, if we want. I don't know. I just usually show the improve and then I talk about the alignment and the entities.
Yeah, carry on.
But we could want to do that first to orient the views. Okay, so yeah, so then we have the brush. Then we have obviously the connect. So everything that's, all the triangles that are touching each other is what will be selected. Then we have sudden change. So if I click that, it's sort of like gonna stop at where there's a radical around. In the modifiers, if I want, I can also grow or shrink. So that's adding or removing a row of triangles. This is very dramatic over here because of the way my triangles are. Because they're so big. That's why there's such a big change when I expand the row or contract it.
And the tolerance, how does that relate to?
That's kind of like, well, if I play with it, it just sort of like allows more connected triangles within the initial sudden change. If I increase it, I'm closer to the edge of where it changes. If that makes any sense. It's sort of like allowing more.
Increasing the radical change scale,
Yeah,
right?
yeah.
So it's like not so much change, so we're gonna fill it, and then this is large change, so this is where we'll stop.
Exactly, you couldn't have said it better, yeah. Here, so that's that guy. The one modifier also I didn't talk about was the select back face. So if I go here and I go with the brush and I do this, you know, it'll let me select that, but if I go underneath, I can't select the gray underneath unless I choose this modifier over here. Then it'll let me choose. Then it'll let me use the gray as an actual selectable face. So sometimes that can be handy to be able to select underneath our blue surface at a specific angle when you got specific geometry or something you're trying to fill. So that does it for the modifiers. I was at sudden change. The next one is similar curvature. This one's maybe not going to work out great for this particular part. I'm going to see if it's going to select something. Yeah, no. That is really the tool for selecting holes, cylinders, spheres. We don't have that here. It's too sharp, it's too straight, too.
Right.
Then we have, this guy we'll use a lot, that's similar normal. So that's perfect for selecting a plane. So if I go here, I'll do this. So it's gonna select everything that has a similar normal.
So what do you mean by normal? Like it says like a flatness, similar flatness, or?
If I use this pen. Okay. This face, right, the triangles, they have a normal.
So perpendicular.
Yeah.
Perpendicular, okay.
So each one of these, it's pointing the way the pen is. But if I go over here, whoop, the normal veers off.
Okay.
So I'm not gonna pick that. It's not gonna, I mean, the selection tool is not gonna It's gonna stop at here and not go around.
It's like it's aspect.
Kinda. So very useful for when we're creating planes. Pick those nice flat surfaces. Then we have this guy here, which is isolated patches. That's very, very similar to what we had in VXScan before of, you know, basically it's just a slider you play with to remove any kind of floaters. The larger you move that, the bigger the floaters will be in your selection. We've already gotten rid of them with our clean mesh and keep only and all that. We really don't use it a lot.
So unconnected, basically.
Yeah.
Floating.
Yeah.
Okay.
Then we have curvature selection, so that really narrows it to edges. That's specifically selecting radiuses and corners and edges. Very rarely used, unless we want to maybe enhance. Then we have the painful one, but it can have its use. That is triangle picking. And yes, that really is what it sounds like. One triangle at a time. So if you have a cleaner that's holding by two tips or something and you don't want to start like having to manage views and make sure you don't clip anything or stuff like that, you can go ahead, click those few little triangles. Once it's a floater, you do your connect, invert, and get rid of it. That's pretty much the only time I've ever used it. Other than that, unless you want to, just really a specific area you want to get rid of those triangles. And the last one is boundary selection. So that highlights everywhere the mesh is open. So everywhere there's a hole where there's missing data, I can, you know, it becomes purple and I can do something with it. So that's all the selection tools, and those are the same whether you're in VXScan, VXModel, VXInspect, always the same ones in the same place. There's no change there.
That last one, when to select it, can you just fill it? If there's a hole and you just select
This guy here, yeah, I'm gonna do that, but in the proper tool,
Oh, it's.
in the hole filling tool. So I'll do that for now, okay. So now basically, yeah, I can start filling holes. So I'm gonna go over here to my improved team, my orange team, and I'm gonna say fill holes. So this is full automatic, low curvature. If I go ahead here and I click on this guy, boom, it just filled it pretty decent. Okay. Now to fill my bottom here, what I can do is say instead of low curvature or high curvature, say flat. So I'm forcing a disc. I'm forcing a flat fill. If I go ahead here, click this guy.
Did you click and drag or you just clicked?
Nope, I just selected flat. I hovered over my pink boundary. It became yellow, and I clicked it.
Okay.
So it did pretty much flat fill. It's pretty much a disc. For sure there are a little bit of waves on the ends because it's matching the jaggedness of those triangles, right? So I don't like that. I can improve that. So I'm gonna cancel out. So instead of my edge being so jagged, okay, I'll start by filling this guy hole. Get this guy there again. Okay, I'll hit okay there. So,
Sorry.
right, because I find that it is kind of dimply, it's, you know, it could be cleaner. So what I'm gonna do is go over and say edit boundary. And now I have a choice. I can do multiple, partial, or fit to an entity. I don't have an entity yet, but what I'm just gonna do is go ahead and do this. So now we see that I have a green projection line. It has appeared. Oops. And what it's doing is it's averaging out my triangles. Now if I increase the tension, see how much more smoothing it kind of happened there. The compromise though is now it will be round here because it averages it out everywhere. But my edge is going to be a whole lot straighter. Won't be so jagged. All the triangles are going to come and meet on that line. So if I hit apply, so now it's a much straighter edge compared to what I had before. And now if I go ahead and flat fill, I'm not so jagged anymore. Yes, I still have jaggedness on this side, but this side is not so wavy anymore. It's really what practically flat now, for real. There's no repercussion of triangle height differences. And now I'm obviously a lot closer to being completely filled. So I'll go ahead and accept that. So again, without the trouble of flipping it over, scanning it, merging it, I think, in for real practice, live practice examples for you guys, I think this is a good way out. Another thing we could do is, if we want, we could keep like despiking. And if I increase the slider, it's gonna make it that much smoother. If I hit apply. And it's an iterative process. It keeps finding more and more spikes. So if I hit. So it has helped making things a little more smoother, but yeah. Here, if I go back to the stem, yes, it's smoother, but it's still not what I want. So here, I think this is gonna be a little more, this is gonna be a little tricky because we don't have the sculpting tool. But if I go ahead here and make my brush super small, and try to save. Whoop. Oh, I see. My triangles are too big, probably. If I go here and I do, okay. Okay. Everything is still doable. There's just a little more gymnastics. Okay. Yeah. So this is actually kind of cool. It's kind of giving me a bit of a mental workout. So like I was mentioning before, there's no like what I was mentioning about like that. You could paint and locally increase the resolution just in your local selection.
Right.
We can do a pass here relatively similar. We're just gonna cheat. We're just gonna go through the back door here a little bit. So I'm gonna take my brush, and again, I'm gonna make this bigger, and I'm gonna select the whole thing over here. Okay, I'm gonna select this, select that, as much as I can.
Could you use the through thing?
Yes and no.
Are you holding control or anything down?
Yeah, I'm always holding control.
Okay. It's amazing. Captured that.
the metra scan that we have can go down to 0.1 millimeter resolution. We guarantee a result of 50 micron accuracy. But it's also $160,000. Okay, just for okay, this should be close enough for what I want to illustrate. So when I was running my line, right, with my little brush before, it wasn't picking anything up because the triangles were way bigger than my actual selection with the little brush I had before.
The circle was small.
Yeah, the circle was a lot smaller than
Some
the triangles themselves, right?
Okay.
Now, to go around that and to go in and really be able to trim where I want to trim, and then after that, extend the boundary further down in, although we've lost the resolution, the real resolution of the object itself, now that it's an STL, we can still remesh it. We can still refine it. Then I can preserve the boundary, and if I hit apply, it's given me smaller triangles. And I have more to play with. My little brush can now have more triangles to play with. If I hit OK, and if I hit refine again, preserve boundary, apply. I have to do this iteratively. In our new version, you can just enter a value of the mean triangle size that you want. But now I've already made this locally, just locally, a whole lot more defined in a sense. I have way more triangles to play with than I did before.
So it's made really, what were really, really small triangles, extremely small as well, right?
Yeah.
You did have some really small guys in there.
Yeah, and now I think I'm gonna do it one last time. I'm gonna push it a little bit. So boundary, apply. Okay, that's small. That's good enough. So now I can definitely come in, start cutting away, and then I'll be able to do the opposite. With the tool next to it, I'll be able to say decimate, then make them bigger again, bigger again. But for now, for what I'm trying to accomplish, I want that nice precision to come in and be able to just select what I want with the brush, to clean out the cleaners in between and be able to extend the boundary down. So now I'm gonna clear my selection. I'm gonna go back to the brush, make this way, way, way smaller. Why did it not grab anything? Okay. There might be a bit of a bug. Okay, that's better. That's better. Okay. Try this again. So again, here the goal is I'm really just trying to be more of a surgeon. Okay. And just try to lop off.
Can you select with a straight line? Like, can you press?
I could,
Shift.
or with the freeform. Oops, the freeform is actually a better idea.
Oh, I see. That's it.
Thanks, that's it. Okay. Let's see. don't wanna necessarily waste a lot of time in trying to clip like everything, as long as it becomes a floater,
Oh, I see.
I'll be good. I'll be able to isolate it. See, do I wanna keep that? Yes, I do. This, maybe not so much. That's not connected, that's not connected. If I hit delete, okay. I'm not necessarily gonna do this perfect there, cause we do wanna do some other things today, but you know, with the proper amount of patience. See, okay. Oops, delete. Now, I will use my connect tool. Oh, I'm still connected somewhere. Where would that be? La, 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 la.
It's still quite a process just to do this, isn't it?
Yeah, it's, oh. Yeah, okay, I'm still connected right there. Those two tips. So sometimes, like I was illustrating, if you just go ahead and select this guy and that guy, you know you're not connected anymore. There we go. Again, I iterate with practice, with patience. Okay, so just to I'm gonna invert, hit delete. The good thing is, because we're in VXModel, I can always undo. We'll
So
forward
it's when you
backward.
export that you can't do anymore.
Well, it's not just that. When I'm in VXScan, there is no Control Z. If I delete something, it's gone. In VXModel,
Okay, yeah.
I can go back and forward. It depends on my save.
Mhm.
Speaking of which, this would be a good time to save. It's not a session. I don't want to save it as a. Oh, it's because it's the file. Okay, because we sent it in VXModel without opening the mesh separately, it's still a session file. So I would have to. Okay, I would have to export this as an STL the way it is. For now, I'm just gonna cancel. I'm gonna save as and call it bookend session 2. Just so we can always pick up to the original one should we not like what happened here.
So once you save, you can't go back.
That's right.
Yeah, right.
Okay. So it looks like we do have the stem. Now, in theory, I should be able to extrude the boundary. Right. Oh,
That's gonna close the stem, isn't
yeah, that's a little much.
it? The lower wall you could, like the vertical.
Oh, it's asking me to select a plane. Okay. It's because it wants a plane to project it to. Mesh by curve.
Well, you know what, maybe.
Extend boundary, sorry. So a beginning, an end, and a center. I don't want to necessarily extrude the whole boundary, I just want part of it for that, the stem part of it for now. Okay, it's screwed up. I'm gonna do something else that might help it. If I edit the boundary, if I edit this guy, and do 60. Okay.
What was the 60, like the number of vertices?
No, it was the strength of my averaging out of the,
So you're smoothing it out.
yeah, I'm smoothing out the boundary. And another thing I'm gonna do, which is another thing I wanted to show anyway. I have this weird surface going on. That is a little strange. Okay. That is a little strange here. Okay. Get rid of. What? Okay. Just trying to get rid of that screwed up upward surface. Now, what's going to help a lot, now see how good the algorithm's going to do it for us. If I go back to fill hole, but this time instead of saying, hole, I'm going to say bridge. Say a low curvature bridge, and I'm going to choose a beginning and an end. And then I'm going to choose which side I'm going to want it to be. And then I'm going to choose a beginning and an end, and choose. Okay, far from perfect, but we just made a bridge.
Right.
So now we have, if I go back to just to illustrate, I no longer have the same kind of hole to fill. I have two holes.
Right.
So I'm able to take a little long. If I do low curvature and I do this, whoops. I mean, not perfect, but I now have a much better, I'm more controlled in what it is I'm trying to fill. I'm sort of coaxing it to what I want it to be. As opposed to if I just did watertight, it's just gonna give me a big blob. Like if I hit OK here, and then I hit watertight, it's gonna create, because I checked the keep original mesh, it's gonna make a copy of this, but all stitched up full of like no more holes. But we're just gonna have like a blob, as opposed to the stem.
So the sculpting tool in the newer version is a better, easier.
That would have made my life way easier, because you just dress the, whatever, you could even, you know, plug it up and then just hit the sculpt, push it down by how many millimeters and just drag it into the rest of the leaf. And I'd have my stem, and I'd have it, yeah, so there, so you see how it sort of filled up all the holes. See where the gray is now, so if I hit OK, that is my copy mesh 1 watertight. So it is watertight, but I don't really have a stem.
We lost the depth.
Yeah. But I was hoping that I could sort of like recut the stem, extend the boundary down, and then partially fill a hole at the bottom, and that would give us the stem, you know, instead of using the sculpting tools. But I mean, yes, I could.
To do that, it'd be nice to maybe take that weathered stone that we talked about and just create a new mesh that's cleaner. You know, get rid of those.
Yeah.
Get rid of the
Another thing that would be fantastic, but you don't have it, is the sandpaper tool. Because that's really like a piece of sandpaper. You choose the strength, so that's the grit, and then you use like the brush. You wave the what you call it. You wave like the brush on top of the surface, and it evens it all out. And it really does act like sandpaper on the mesh.
bigger spikes.